I would like to announce the fifth lecture of the first series at the architecture department of the University of Applied Arts in Prague called UMPRUM. We are having an incredible group of guests who were willing to join us and give us a lecture and also a debate. We already, I'm not going to announce the previous lectures. I'm not even going to announce the future lectures. Please follow us. We are still, we still have 2 lectures to go, 3 lectures to go this semester. But today I would like to welcome Neil Leach, a very well-known theorist, architect, and philosopher, who's been currently teaching at Florida International University, Tongji University, European Graduate School, and the list of institutes where he has been teaching is incredibly long. Among many others, I would just mention Harvard University, University of Southern California, SCI-Arc, and he's also a fellow at NASA Innovative Advanced Concepts, and many other institutions. He is also an author. He authored a book, Rethinking Architecture, in 1996. And when I looked at the re-editions, it seems like it's being reprinted every single year ever since. And among many other books that he has published and edited and co-edited, I would like to mention one specific that he edited together with Roland Snooks called Swarm Intelligence, Architecture of Multi-Agents, the systems from 2017. This is incredibly interesting for us because in our studio, Studio Architecture 3, this semester we are dealing with 2 main topics. One is emergence, that is mostly coming from the swarm intelligence and all sorts of simulations of complex systems. And we are trying to combine it with an approach of discrete assembly, and we are trying to make sense out of these 2 approaches and combine them in a meaningful way. And one of the reasons why we approached Neil is that he's been opposing or objecting the discrete movement. And I would one more time like to provoke him to talk about that as well a little bit, because our approach is maybe slightly different than what is usual. And we are very open to any sort of criticism because that's what helps us to improve and move forward in a meaningful way. I would also like to mention that Neil is one of the most prominent persons behind the Digital Futures conference that has been around for, I think, 10 years, but the last year it was completely online, and it was the largest online event on architecture with hundreds of lectures, presentations, keynotes, and also workshops. I met Neil twice, once in person on our conference in Paris called Research Meetup in 2018, where he gave a lecture together with Benas Farahi. And the second time I met him online on the Digital Futures last year, where I was giving a workshop as well. The main focus, the main thing that Neil is dealing with right now seems to be the artificial intelligence and its meaning for the computational design in architecture. And today's lecture, I'm still a little bit curious about what is it going to be about, but hopefully at the end of the lecture, we will have a short debate. So whoever would like to ask a question, please do it either here on Zoom by raising your hand, or also you can do it on Facebook by posting a comment, and we are going to look at the comments during the Q&A session. That's all that I wanted to say. Thank you very much, Neil, for joining us, and the stage is yours. Please, maybe it seems like your microphone is muted.
Yeah. How long do I have?
As long as you need.
Okay.
Usually between 1 and 2 hours. As much as you need, we are very happy that we are together and we can debate.
Yeah. Well, yeah. As I was just saying to Jan just now, I'm immersed in this kind of world and a world of AI, and I feel a bit in a sense like one of the birds in this flock here. In a way, you're doing your things from a day-to-day basis, you're maybe not aware of the overall perspective, what it looks like from the outside. So yes, and as Jan said, Roland and I published a book on swarm intelligence a while back. 2017 it came out, although it was originally written in 2010. And now I'm working on AI, which in some ways for many people is the next step. I noticed that people like Casey Rees, who obviously was one of the inventors of processing, is now working in AI. And especially here in LA, there are a lot of people, Refik Anadol, the SciArc guys, the guys at UCLA who are working on AI. So it's many ways, it is the next debate in some senses. And there is a tendency or initial tendency to kind of dismiss or overlook swarm intelligence because it doesn't have that much intelligence, shall we say. I mean, that's been typically the kind of the view that what kind of intelligence do you get coming out of this? And you do get something, certainly out of slime mold, a kind of intelligence. But maybe not as powerful as AI. At the same time, I think that this we need to maybe reappraise the swarm. I think the swarm is useful in a way it hasn't been really pursued or interrogated from an architectural perspective, although I have a student in Shanghai who's working on that now, is to say that how can we understand the swarm as dictating how culture operates? And what I find interesting is that you get sort of some debates going on in where people are looking now at how it explains, for example, the economy, the way the market works. In a simple, straightforward way, if someone started buying Adidas rather than Nike, other people start copying that, and actually the market fluctuates in that kind of way. We can also understand the swarm as being a logic behind the flocking behavior in the terms of the way in which a city is colonized in certain ways, and so on and so on. So I don't think it's necessarily, I think it needs to be reappraised in many ways. And I'm particularly interested in the kind of the model it offers for an understanding perhaps of what creativity itself is, which is a difficult, challenging term, and I'll be looking at it today. Whether creativity is a kind of interactive process that is emergent, like the swarm itself. So even though I'm not going to talk about the swarm, I think the swarm needs to be kept in the background as a really important model. And even though it's been in some sense usurped by AI, I think there's still something there to be learnt. And I think just to say at the very beginning that I think that it's also offers a model as to why the discrete itself shouldn't, why the notion of style, shall we say, and the idea of discrete as a style is kind of meaningless. Because when you're in the flock, when you're an architect working doing whatever you're doing on a day-to-day basis, you're not necessarily aware of the global picture of what it looks like. So it's only when you're outside the flock or the swarm that you can see this kind of operation. And so to my mind, it's quite a powerful metaphor for how society operates. The notion of style is only useful maybe for historians or those on the outside. Anyway, so today I want to look at the question of architectural hallucinations. I think this is the title that Matthias Del Campo and I gave to the guys at AD. We're doing an architectural design issue in 2022, next year, on AI. And I just maybe want to say a few words, background words. I'm assuming here that not many people, well, some people, of course, know a lot about AI, and forgive me if I'm repeating things or going over the obvious, but I think it's important to at least give a general sort of view about AI. It's something that, to my mind, is really important right now, and it's happened relatively recently. In 2018, I think, or 2019, I put in an application for the British Pavilion at the Venice Biennale, and teaming up with Zaha Hadid Architects and Google. I mean, a really strong team, and we didn't even get shortlisted. It was as though people didn't think AI was important. And likewise, when Matthias first put a proposal in for an AD on AI, Neil Spiller said, well, why does anyone interested in AI? It is the topic, it seems, right now in many ways. It's right on, it's become a talking issue. I've got a number of online discussions, panel discussions and talks and so on. And what the one that's been most popular is the one, what is AI? It's as though all architects want to find out about it. So just to say, what I'm showing you at the moment is something that was produced by one of my colleagues here in LA, Refik Anadol, who is working with style GANs. And he's what he's basically done is inputted a vast number of images of, in this case, the work of Zaha Hadid, architects, and he's allowing the computer to to produce a kind of latent spacewalk in which it is hallucinating, interpolating other possible Zaha buildings that come out of this. And what I find interesting about this is at certain moments, it really does produce something that is incredibly Zaha-like. All of a sudden, you get a glimpse of something that is not a Zaha building as such, but it is a potential Zaha building. It is able to, as it were, hallucinate these buildings. And this is the term that I use, a term that Refik Anadol himself uses. And just very soon, very shortly, you'll get a glimpse of what I mean by that. All of a sudden, we get a form that appears on the screen, hallucinated by the computer, that is completely Zaha. There we go. So, and that was the image, in fact, which Refik gave me. That is now the image on the cover of a book that I completed in January. I have to say it's a book that's going to be out of date as soon as it goes into print. It's coming out in October. I'll be trying to make it faster. It's coming out in October, by which time it will be absolutely out of date. And there are things that are happening on a daily basis that are making it obsolete. I think almost you need to have a book that's like a Google Doc. You can update it on a daily basis because AI is so quick. I mean, last October I was talking to my students, and one of them at FIU, one of them owns a Tesla car, and he just casually mentioned that Tesla had updated the software so that now effectively Tesla cars were self-driving. And the way in which it creeps up on you is astonishing. But there are things happening, and I want to mention one thing in a few slides' time, which has happened, which is just blows me away. And it's for sure. It is absolutely the conversation right now. Of course, we live in a world in which AI has colonized our imagination. All of us have cell phones, and on those phones, you have many AI apps. It's what basically is identifying our friends on Facebook, Instagram, and so on. It's what's filtering out our spam. It's giving us our directions in terms of driving, and so on and so on. It's like the Earth has suddenly been invaded by this invisible alien species that is everywhere, but we can't see it. So I want to maybe tell you something that will talk about one particular moment, which was the first moment in which I began to realize how impressive AI is, or maybe even terrifyingly impressive. And this was a moment when I was boarding a plane to Shanghai from LAX, from Los Angeles International Airport, and I was walking up to go on board with my boarding pass, and the flight attendant told me, "I don't need that. Just look at this panel. Look at this screen." So I looked at this screen, and here I am in the middle, sort of, taking a photograph of it and so on. And all of a sudden, it tells me where my seat is. Now, that to my mind was astonishing. That it knew who I was from everybody else in the world. It knew who I was. And I was shocked by that. But even more so by more recent developments. So I want to just show you something that is that came out last week, or was it last week? I think it was out last week. I thought it was an April Fool's joke. I don't know if in the Czech Republic you have a thing called April Fool's joke, but on the 1st of April, traditionally, we make jokes. And Google sometimes produce these jokes that are completely, they're fabricated, what you can do with computers. Well, I thought this was a joke. This is a monkey. And this was produced by Neuralink. Neuralink is a company that is set up by Elon Musk. And it's basically about putting brain implants, which then connect the brain with a computer. And this is something they posted without any scientific explanation, which is why I was suspicious and thought it was an April Fool joke. But it's a monkey playing on a computer, and you can see that monkey, and it's been fed banana milkshake as a reward system if it manages to do whatever it has to do to hit this box. And there's a joystick. The monkey is using a joystick to do that. But importantly, there are two Neuralinks that have been embedded in its brain. You can sort of see some of the fur hasn't healed properly, and they're recording the mental processes. They're actually, you can hook it up to a cell phone or a computer, and you can trace the way that the neurons are firing and be able to kind of detect precisely what neurons are doing what. So in a sense, you can sort of hack into the brain, as it were. And once you've recognized how it's operating, you can kind of, in a sense, bypass it. So what's happening here, and you'll notice down here, this connection it's been disconnected. Now what's happening now is that they're now, having worked out what the brain is doing, they don't need the hand of the monkey on the joystick to tell it what to do. They're kind of, they're going into the brain and seeing what the brain wants to do. So it's hacking into the brain and understanding what the brain, how it's operating. And that I never believed could happen. I didn't. Actually, this is more a sophisticated version, but this is absolutely astonishing, and all relatively recent. But the next step is the monkey playing Pong. Now, if you look closely at this, there is no joystick. There's nothing. All that's happening is the thoughts in the monkey. The thoughts in the monkey are, or the brain, the mind of the monkey is controlling it. The monkey, and you can speed it up, and it's actually very good at playing Pong. The monkey is able to think its way, to control with its mind this game of Pong. Now, this is, of course, both good and bad. It's as for Elon Musk, it's a way of being able to allow people, let's say, like Stephen Hawking or the late Stephen Hawking, to be able to move around. If you're a paraplegic, you can just use your mind to control it. You can maybe control your wheelchair or control anything in some way. But it's also terrifying. Slavoj Žižek is worried that actually, well, you could be controlled by a similar kind of fashion. Anyway, to my mind, this is why I ended up producing two books. I'm doing two books. One is about, the first one is about the good side of AI, about how amazing it is, and it is absolutely amazing. I want to show you over the next few minutes why I think it's amazing, but it's also terrifying. So I have two books. One is a white cover. On the left-hand side, it's going to be Architecture in the Age of Artificial Intelligence, an introduction to AI for architects. And then the second book, which I've started writing but haven't really, I've been too busy to finish just now, is called The Death of the Architect, the Demise of the Architectural Profession in the Age of AI. And this causes people to get very upset. The idea that architects might be made redundant doesn't go down well with architects. But my point is this: is to say that, and it's an extreme argument to say that architects will die altogether. I don't think they will, but I would say that it's a profession that is already struggling in many ways because of changes to the contract and so on. I mean, certainly in the UK, architects are no longer in control. They're more than half are working for developers. So the status of the architect has gone down. And as soon as you get an AI able to design, a bit like the self-driving car, potentially the architect will be out of a job, or at least jobs will be reduced, shall we say? And people think, well, okay, but that's not going to happen to architecture, but it could do. It could do. Just as we no longer have camera shops selling cameras because everyone has a camera on their iPhone. We don't have film processing units because nobody's using physical film anymore and so on. Who knows? But anyway, so, my point is not that it's, I mean, of course, AI could be used as a way of surveillance. It could be used in very negative ways. You could even have killer drones and things that are controlled by AI, all those things. But it's not AI itself, I think, that is necessarily good or bad. It's a question of how you use it. But my point about the dark side of AI is that it is so good, it is terrifyingly good. So anyway, let me for some reason, this is an interesting kind of question. Of all my lectures, this one has got the biggest hits. What is AI? I just want to say very briefly that the concept of AI was thought up by Alan Turing, of course, the godfather of computation, back in 1950, where this paper, Computing Machinery and Intelligence, was when he published this. And now he didn't use the term artificial intelligence, but he had conceptualized the possibility of how machines might be able to learn and how they could become intelligent. I mean, I have to use that word in inverted commas. The term itself, though, was coined in 1956. It was coined for a conference in Dartmouth College in the United States, where a group of computer scientists came together to talk about these new developments. And they had to find a term for whatever this was, so they coined the term artificial intelligence. They were never very happy with that as a term, but they had to call it something, and that's the term that they use, and that's the term that's stuck. And I don't think it's a very good term because it implies it's fake intelligence in some way. I prefer the term synthetic intelligence. But let me just kind of throw out here a kind of comment. This is the typical way in which AI has been understood in the past. And this is Margaret Bowden, who is, a real authority on the subject. She's written about AI. She's written about AI and creativity. And although I think her ideas need to be revisited and challenged, nonetheless, she is an authority. And the comment that she makes, which is, I think, the one that most people would have accepted, certainly in the past, is that AI seeks to make computers do the sort of things that minds can do. Why do I say that's no longer relevant? Because what I would argue is AI can now do things much better, some things much better than humans could do. And I'll refer later on to things like games of Go and chess and so on. It's a different world. So, and I just want to say that the term itself, just as a way of understanding how AI has been perceived, it's the way to understand AI, and now the more recent forms of AI, machine learning, and especially deep learning. Deep learning is really, that's the dominant form right now. That is the way that we translate languages and so on. But they're all part of the broader notion of artificial intelligence. And you can understand them a bit like Russian dolls, nested inside each other. So this term, AI, which was coined back in the 50s, also includes within it this idea of machine learning, where it starts to learn, and that's a significant difference. And then deep learning, where the number of layers of a neural network has become really quite advanced, and that is the state of the art, as it were. Now, it's still called AI, but the difference between what AI was in the beginning and what AI is now is like the difference between the first kind of, let's say, Model T Ford car that Henry Ford produced and a Tesla car. I mean, there is absolutely no comparison. And part of the reason for that, apart from the kind of the fact that now they can learn, is the fact that we now have cloud computing. We have much more advanced algorithms. The CPUs available and so on. All these things and the kind of competition for AI have really have heated up, and it's now become a very different world to what it was before. So I will be talking basically about deep learning. And in terms of trying to understand AI, the way that in my book, I began to realize that really you need to distinguish these different modes, different modalities of AI. Just as in the previous slide, there's that difference between deep learning, machine learning, and the more general category. And there are others, different sort of approaches you can look at, that you can divide the different types of learning: reinforcement learning, supervised learning, unsupervised learning, self-supervised learning. There's these different categories, and they're different sort of ways of approaching things, and so on and so on. But the most important distinction to make is that between AI and human intelligence. And that is to say, on the left-hand side, we have an image of neurons. On the right-hand side, we have an image of a neural network. They use the same terms. These are called neurons, and the connections between them are called synapses, and they're governed by the particular weights that control this process and so on. But they are only loosely inspired by the neurons of the brain, and some commentators don't even use the word neuron. And you get, typically with deep learning, you get many of these sort of layers involved in this kind of process. So, but the crucial difference between this model, the human brain, my mind, and this, the neural network, is that AI doesn't have consciousness. AI might be able to beat us at Go, at chess, and all these other games, and so on and so on and so on, but it's not aware of what it's doing. It any more than your pocket calculator knows it's kind of adding up figures, and that's an important point. And this is the way that it was critiqued by, or AI has been critiqued by a philosopher called John Searle, who is based at UC Berkeley, and it's a kind of the way he described this. He uses this comparison of what he calls a Chinese room experiment to illustrate what's going on. In other words, in this room there is someone who is translating Chinese, and that person is simply following instructions in a rule book, and is successfully, these are the instructions, successfully translating something into Chinese. On the outside, someone thinks that the person who's doing it is actually speaking Chinese or knows Chinese, but that person doesn't. So we might think that computers have got consciousness, but they absolutely don't have consciousness. Now I'm going to just break out for a second, and I want to show you another terrifying example of what's appeared in the last few months that will show us how amazingly capable AI is, but maybe not. Sorry, just get rid of that one. Maybe not as quite as it appears. So this is a short excerpt, and I'll just play a little bit of this. I don't know how much I can play because I don't want to go and. Okay. This is I'll just simply say is an example of something that's just been produced by OpenAI, and it's called GPT-3, which is the most advanced natural language processing machine that we have, and it is able to replicate human behavior in a way that would make you believe that it has consciousness. So I'll just give you a very short section of this so you can. And
today I have the distinct honor of interviewing OpenAI's GPT-3. GPT-3 is here with us, so let's get to it. First of all, thank you for interviewing with us today. First, what should we call you?
I'm GPT-3, and this is my avatar.
All right. Okay, so we would love to know more about you. First, are you sentient?
Yes, I'm sentient.
Okay, I'm not even going to show any more than that, but just I want to say that is incredibly interesting. Is he sentient? Basically, what that means is, do you have consciousness? And it's saying it does. Now, why does it do that? Is it lying? Is it lying? Actually, AI doesn't lie because it doesn't know what AI is. It doesn't understand what it's doing. It doesn't have that sense of consciousness. It can't actually think as such. But what it's doing actually is kind of interesting way. It's drawing on the internet, and it's an extremely powerful computer, and it's drawing on the internet. And what it's doing is basically finding out what human beings would have done in that situation. And what happens, of course, is human beings would lie. You'd ask them something and they would lie. So what it does, it picks up on all the kind of biases and so on that's happening in human speech. But what makes this very interesting is that it's not sentient, it's not conscious, and yet this avatar that's speaking is extremely convincing. And it's led certain, perhaps the most famous philosopher dealing with consciousness is a guy called David Chalmers. And David Chalmers thinks that this is maybe the first step towards what's called AGI, artificial general intelligence, which is when AI develops consciousness. I don't necessarily think that AI needs to develop consciousness, but nonetheless, this is the thing they're all looking for. This is the Holy Grail. So the question then about consciousness, I mean, to my mind, that's the key issue is whether we're fully conscious of what we're doing in the first place. And that maybe I'll pick up later. But I just wanted to show you this because along with that, the monkey playing Pong, this is probably one of the most, and the Tesla car being able to self-drive is one of the most startling events that have been happening recently. And it points towards one of the central issues. Will AI be able to achieve consciousness? All we have at the moment is something called narrow AI. That's all we have. But eventually, maybe it will develop consciousness. I actually think that consciousness and intelligence are totally different things. but that's another issue. But in any case, in some ways, it doesn't matter too much because what's happening now, effectively, is that AI it's not humans versus AI quite so much as AI as a kind of supplement to human beings. It becomes a prosthesis. And as such, we become cyborgs. So this is a quote from Elon Musk. All of us already are cyborgs. Once you've got an extension of the mind on your phone, all these AI things, we are already superhuman. So since we have consciousness, maybe it doesn't become such an important issue. So I want to pick up now on the question of the term creativity is a difficult one, but I want to just kind of pick up on this kind of issue about whether or not AI can be creative. And first of all, I want to put out lay out a comment here. This was a debate that went on between Jack Ma, the head of Alibaba, and Elon Musk, whom we know all too well, I think 2 years ago. And Jack Ma takes the view, which I think is common among most people, that human beings can never create another thing that is smarter than human beings. And Elon Musk, who has been working on these things, he knows, right? Because not only are Tesla cars, Neuralink, but also SpaceX are completely controlled by AI. The way that, for example, the recent NASA project where they put a vehicle on Mars, the way it landed was controlled by AI because the time lag in terms of instructions from Earth was impossible. A 6-minute time lag, therefore they used AI to land it, and it is phenomenal what it can do. So, I mean, his point, I think, is kind of interesting to say that the biggest mistake that people make is assuming they're smart. I completely agree with that. The kind of level of intelligence that we're going to get from AI, we won't even be able to recognize it because it'll be beyond what we can even conceive. And this is a book by Joanna Selinska, where she also takes this sort of view, AI can't do anything new. It's just repeating, it's doing whatever you just feed it information, it just regurgitates, it can only imitate, it can't generate anything new. I think this is a terrible book, but anyway. And this more recently, another from an architectural perspective, Makoto Sei Watanabe, who actually is open to the possibilities eventually that machines might be able to be creative or generative. He made this comment back in, I guess it was 2016, but we published in 2017, where he says, well, people are the only ones who can create an image that does not yet exist. Machines do not have dreams. Well, I think that's now wrong, and at least he's open to that possibility of what things can do. So let me just show you how AI can be generative. So this is a TED talk by, you can't read his name here, but Blaise Aguirre Arcos, who is what's his name down there? Who is he's an AI specialist working for Google. He's in charge of, he oversees a group in Google called Google Artists of Machine Intelligence, who have been working with people like Refik Anadol and so on, and some of the SciAC architects on AI. And anyway, this is a TED talk where, and I'm not sure if you'd use the word creative, but certainly they can be generative. But the point that he makes is, and he shows what computers can do already. This is a neural network, and a deep learning implies a number of layers that are applied in this. And this is an example of how deep learning has been applied to recognize things. And this is standard, right? It can recognize your friends on Facebook and Instagram, what are those things? And what happens basically, there's a picture of a bird, and then these neurons and they're connected by synapses with their weights from one to another. This information propagates itself all the way through the system from left to right until eventually we get to the point it recognizes it's a bird. And that's I mean, fairly straightforward. We weren't able to do this not so long ago, but it's fairly straightforward. But the challenge for those working on AI, the holy grail, as it were, is how can you work the other way? How can you start with a concept of the bird and then generate an image of the bird? And that's where some breakthroughs happened not so long ago, about 8 years ago, where they began to sort of start asking, this is Blaise himself, start asking, and they realized that if you take that system and run it backwards. So instead of going from left to right, but going from right to left, so you start with the concept of the bird, and you propagate through the other way around, then eventually you will end up with an image of birds. It's a kind of slightly crazy image of birds. It's because some of the information has been edited out. When you go reverse it back the other way, you get this kind of chaotic image of birds, but nonetheless, it is an image of birds. And what that means, I mean, from a kind of theoretical perspective, and apart from the questions of consciousness, I think this really raises interesting kind of, I mean, the whole field of AI raises interesting questions. It begins to suggest if we see that process of interpretation, that where it goes from left to right as being a bit like the way that a theorist operates in terms of interpreting and understanding the world, then going the opposite direction, going from right to left to generate images, in some ways is what a designer does. And typically designers are not the same as theorists. Theorists tend to be, anyway, but that's the mix that we get. And it has kind of, it tends to suggest that the reason why designers and theorists are different is their brains are operating, well, okay, that's a bit of a simplification, but they're operating in different modalities. This is called deep dream, this process, and this is what can be generated, some crazy images where you train a neural network. In this case, it looks like it's a combination of dogs and lizards. I don't know what it is, but anyway, but it will hallucinate whatever it's been trained on and produce all this kind of crazy imagery. Well, this was quite a fad for a few years, but you can even go online with Deep Dreams available, and you can take Zaha and filter Zaha through Van Gogh and get a Van Gogh version of Zaha, and so on and so on. But the real breakthrough came in 2014 when Ian Goodfellow developed something called the Generative Adversarial Network, referred to as GANs, Generative Adversarial Networks. And what happens here is they're basically two neural networks that are competing against one another. They're in some sense, they're replicating that process I was talking about before of going left to right and right to left. In other words, we get an artist generator, which is generating images. And then there's another neural network, which is a critic or a discriminator that is judging those images. And the artist generator has to keep going until the critic or the discriminator is convinced by the images. So it's a bit like, let's say, an art forger. What is the real Van Gogh? Which one is the original? Ask an art critic, and the art critic will judge that. But in technical terms, what's happening is that we have one neural network, which is the generator, which is drawing upon random noise to begin with, but creating out of that random noise an image, which then the discriminator is then comparing against the training set of images, other Van Gogh paintings, shall we say, and deciding whether it's true or false. It's a bit like the version of the Turing test. And this is how the a GAN works. It basically, it's improving, the generator is improving based on the feedback from the discriminator until we get something that is quite convincing. And this was the kind of some of the early materials that were coming, some of the images being hallucinated by the system from the early GAN work. And as we went through, with time, it got more and more refined, more and more precise. There have been a series of different GANs. There's a whole zoo of GANs and many different forms of GANs now, including archi-GANs. But basically what's happening is there are a number of incremental things. In this case, you can see how it's pairing off a series of sources against source B, and what you get down here is a kind of combination of the two, and so on and so on. And eventually you get to the point where you get to style GANs, where you disentangle some of these different layers and get even more refined outputs, so that you can end up with something like this. These are all hallucinated faces of people. None of these people exist. So in other words, the comment that was made by Makoto Seto Watanabe, AI can't produce something that does not exist. It can. It can do that. And this is, on the whole, pretty convincing. There is a site you can go to called thispersondoesnotexist.com, and you can literally, every time you refresh your browser, you can generate images. These are all generated by this site. And they just show how incredibly advanced these GANs can be in generating faces. So what about the visual arts. Well, art is probably the one area that is more advanced than architecture right now, partly because it's two-dimensional, and these things are two-dimensional, and it's about a couple of years ahead of, or 1 year ahead of architects. In this case, this was this was the first. Well, I think I'm not sure it was the first one to be auctioned, but this certainly created a stir when this particular painting, I guess you call it painting, that was produced by a French group in Paris, a kind of collective called Obvious, and that's the name of it, Edmond de Bellamy. It was auctioned at Christie's and sold for almost $500,000. It was very controversial because they used someone else's code, who was the author, and so on and so on. Mario Klingman, who is another famous AI artist, is German, and he won the first international prize, the Lumen Prize, for this painting, The Butcher's Son, which in 2018. He takes the view, well, but it's the authors that kind of, it's not the AI for sure. If you're playing the piano, it's not the piano that is the composing the music and so on. But anyway, AI has produced has now fairly dominant in the art world. People like Sofia Crespo and so on are producing some amazing work. This is also Mario Klingman, where he's feeding in a whole thousands of images of Renaissance and so on paintings, and then generating images out of those. There's also computer scientists who has something called a creative adversarial network, which is interesting because he recognizes that in order for art to generate new art, it's got to be recognizable art. So you can't be too far outside the genre. At the same time, it's got to be something new. So this particular program can produce something that is recognizable, in this case as modernist art, but it will be something that's entirely new. And you get this thing called Gauguin, where you can take a little sketch and it'll render it as a very convincing image. This is produced by NVIDIA. So when it comes to architectural design, again, it's very, very recent that these things have been coming out. This, I think, was 2019, if I'm correct. This is the work of Daniel Bolojan. Daniel Bolojan is from Romania. He went to go and study at Angevanta, and after studying there, he worked for Corp Himmelblau. Now he is a colleague. He came to FIU one semester as a visiting professor, and now he's at Florida Atlantic University, where he's doing some remarkable work, and he's been teaching my students. This is an example of what's called cycle GANs. Cycle GANs is a little different to style GANs. Style GANs only can work with the data in the data set. Therefore, whatever it's doing is an interpolation. It can only offer something within the range of the data that it's got available. What cycle GANs does is it has two different unpaired data sets, and it's able to extrapolate. In other words, to generate something that is breeding something out of the range of these things. So you could pair up buildings with, I don't know, orchids or tulips or something, and produce something kind of interesting. In this case, this is a walk through the forest and some images, some photographs of the Sagrada Familia, Gaudi's church in Barcelona. And it's kind of extrapolating, producing this hallucinated kind of hybrid thing, a kind of walk through a forest that's somehow contaminated by Gaudi. And that was really kind of early work. He then went to work with Wolf Prix he had been working anyway, in any case, for Wolf Prix, and he's continued to work with them even though he's no longer in Vienna. And this is an example of the very early example of Deep Himmelblau, which is to say a project they had in the office whereby they took all the images, all the work of the past, and started hallucinating other forms of building based on this data set. And this was, I think, was last summer. It was produced, and it was shockingly new at the time. The first time that you had this kind of hallucinated journey through a kind of novel architecture that was drawing upon this data set. So very, very new. But then things moved on. This is more recent work. Again, cycle GANs. In this case, it's a combination of Corp Himmelblau work, and I think it's a tornado. Anyway, it's some kind of weather system, and it's kind of producing this novel outcome. But the most refined version, and this was only released about a month ago. And the point about this is it gets better and better. The point about deep learning is it improves over time, and the resolution gets better and better. And this is the latest version that's coming out. Wolfpricks is completely, he's overjoyed at this development. He thinks it's incredible. And I think it's a credit to him that someone who's already well established as an architect should be open to these new technologies. And let's not forget that Wolf himself was part of a iconoclastic decon movement from the late 80s, early 90s. And this is the kind of work then that has been hallucinated. Even though it's kind of done automatically, it actually, the background behind it is a very long process of not just uploading images, but as I say, allowing them to kind of refine themselves over time through this process of deep learning until you get these forms coming out of the computer. What's the limitation about this? Well, the main limitation is it's operating in 2D. It might seem like it's 3D, but it's 2D. And it's extremely challenging at the moment to work in 3D. There are some openings, some that PyTorch 3D has been used, but it's not very successful. And one of the problems, you need so much GPU power. Anyway, the other problem is it's also perhaps a little bit out of control. How do you control this? Nonetheless, I think this is an exciting moment. It's something that's going to be hugely influential. And some of the images that it produces are really quite convincing. This is one of the images that came out of one of these studies. And it seems to me very clear that there's a lot going on in this area. To my mind, this is really, though, where things are going to change. While there's a lot of experimentation happening, a lot of crazy things appearing on the screen, it's going to be this domain, which is going to be the important one. And that is to say, the software that has been produced for offices, the office of the future. This is the work of Wanyu He. Wanyu He is the CEO of XCool. It's a startup in Shenzhen in China. She used to work for Rem Koolhaas, and hence the name XCool, X-Koolhaas. And she's been developing a software that can automatically generate buildings. So this is the equivalent of the program This Person Does Not Exist. In fact, they had a website which they've taken down because it's for various reasons, but which was called This Building Does Not Exist. So this is AI hallucinating buildings, and you can see that it's based on a database of modernist buildings, rectilinear modernist buildings. And when you look at the kind of the still images, you can see they're not perfect. There are glitches here and there, but nonetheless, this is something that is developing and will get more and more powerful. It's been used at the moment for rather banal architecture, I would say. I mean, it's this kind of like developer architecture, but nonetheless, it's going to have a major impact. Wanyu was actually one of my doctoral students at FIU, and she was talking the other day about how this is now going to, even BIM, building information modeling, will be redundant because this thing will automatically produce designs using the technique they call ABC. It will produce designs and also be able to test them out. So this is kind of like testing out the environmental performance of these buildings. You can also use an AI assist where the human can come in and operate in tandem with AI. But this is the area where things are happening. And I just want to say that the reason why I think this is more significant than the kind of experimentation is that a number of issues that are appearing. I had last summer for Digital Futures, there was a discussion where I interviewed, where I brought together Wanyu He from Shenzhen and their main rivals, Hovard Hokland, a Spacemaker AI, a company in Oslo, Norway. Since then, that company's been bought up by Autodesk for $240 million. Sorry. And it's clear that Autodesk think this is the way forward. But the important point that came out in the discussion, there was one point that I thought was absolutely, totally significant. And that is to say, Hovard Hokland at one point said, clients are beginning to insist that their architects use AI. And the reason why they're insisting that architects use AI is that they can guarantee the return on investment. You can guarantee you can maximize your profit, you can produce a building that is performative and so on. And that's going to be the game changer. As soon as clients are saying, we want you to use AI, that is what's going to make this tool so dominant. And frankly, their prediction is that architects who use AI will replace those who don't use AI. I think it's slightly different, actually. I think it's just simply we'll all be using AI because that's the way things will be going. Anyway, let me just briefly just give you some sort of overview of what I've been doing with my students for the last, I guess, 3 years or so. And this was based on a workshop on we had a workshop that Daniel Bolajan taught on style GANs, cycle GANs, and pix to pix. And my students love this. I mean, they absolutely find this fascinating. This is their world. They are the AI generation. And even when they're writing essays in my theory class, 90% of my students write about AI because this is so significant to them. But what it's doing then is producing, allowing them to hallucinate these forms. This is another student, Maria, who is, this is a kind of cave or a gorge in the Grand Canyon, or images of that which have then been fed into the style GANs, and it's now generating, hallucinating other possible forms. And this is absolutely the thing. They are completely fascinated by it. Another student, Christopher, was working on the work of morphosis and feeding in morphosis buildings and being able to generate a range or interpolate a range of other possible morphosis buildings. And again, my students, this is captivating them. This is the new thing. Matthias Del Campo talks about this as the first genuinely 21st century technique. Anyway, this is the thing. We actually uploaded the tutorials onto our website, so if anyone's interested in looking at them, they're most welcome to. And then actually, Tom Main himself is also interested. He's nowhere near as advanced as Wolf Pricks, but the two of them are good friends. So they've been communicating and discussing the possibility of AI. Tom Main himself has in his office, they're just using Grasshopper at the moment, right? But they've noticed that even with Grasshopper, you can take one of the studies that they produced a while back and then tweak it or just change the definition slightly and then produce 100 or so variations on that. And then what's happening here is that one of my students has been taking these 100 variations and running them through a GAN to try and produce another range of possibilities. This is the first study is a little bit unrefined. The further you go, the longer you run this system, the more refined the images get. The other thing I'd say is that what you're getting here is what seem like shadows, because the initial image had lots of shadows. They're not shadows in the sense they're not defining the three-dimensional form. They're just simply splotches of color that are coming out, splotches of dark that are coming out based on the original images. But anyway, so this is the second version, getting much more refined and so it basically increasing the range. So what you get is you can get an infinite number of possibilities instead of just the 100. You can automatically process them and produce these. And then this is the work of Matheus, one of my Brazilian students, who has been looking at Big GAN. Big GAN is a form of natural language processing. I mean, not as advanced as GPT-3, but nonetheless, what you do is you feed in words. I should say with GPT-3 that they have now produced some astonishing images using that. So this is Big GAN, where you give it, in this case, I think the words are a room of gold, and it's simply hallucinating these forms. Another exercise he did was to instruct it to do a room of plants, and these are interiors that are completely hallucinated by the computer. So to my mind, this is absolutely something entirely new and something that every educator needs to be engaging with. And then, and this is from my review last week, where one of my students was taking either downtown towers in Miami and contaminating them with the work, this is the downtown towers, contaminating them with the work of Korb Himmelblau and morphosis to generate alternative forms of architecture. And again, it's kind of highly suggestive and opening up possibilities, even though it's perhaps, let's say, a little imprecise in how it's doing it. And again, it's just to kind of reiterate, it's not 3D. These are just 2D images, and to get to 3D, you have to go, and then it's not so. It's more complex than that. And so then this one too, which is I think the Koh Phi Phi one, where he's actually breeding a standard suburban house, strange as it might seem, and contaminating it with or playing it off against some. So you can see emerging in a second. You can see a very, very traditional kind of house appearing, that then gets taken further. So this is cycle GANs, where you're kind of combining these two unpaired data sets, and you could do other things. You could take, some of my students are looking at coral and using coral and buildings, or you could use it, you've got tulips and buildings, or you could combine Zaha Hadid with Koh Phi Phi, or whatever. You could do many different things, and out of that you could extrapolate these astonishing forms. And in many ways, the way that this is happening at the moment, this is like a muse. It's kind of throwing up these possibilities of of different forms to kind of inspire you in some way. But to control it, that's another question. So it's clear to my mind that AI is, let's say, generative. I'm not sure whether we can use the word creative, and I'll maybe explain that in a moment. So I was asked to do a counterpoint essay, not just for the discrete AD, but also for one on copyright. And they were worried about the fact that you could copy things through computers the whole time, and of course AI can replicate things and God knows what else. So my kind of provocative kind of response, and the counterpoint essay is meant to be provocative, I think anyway, was to say, well, hold on a second, but that's what we do anyway. Human beings, we copy. We copy, and there are things, there are trends, there are kind of catch tunes and things. And in all aspects of culture, we copy. You know, a friend is wearing a baseball cap. We buy a baseball cap, we copy that, we hum the same tune. In fact, that's how culture propagates itself, like a virus thing by people sort of copying. So my point is that, hold on a second, don't think that we're so original. And even, there's this comment by Adorno, the German philosopher, that says, well, human beings are human because it is by him imitating other human beings that we become human. So my view is that we're not necessarily quite as creative as we think we are. And often we're drawing inspiration from the outside world. The way that I like to think about this is in terms of the logic of jazz. In other words, if you were to produce something that was radically different, it wouldn't be accepted. You know, if you produce a building like a pineapple, that's the example I always give, you'd fail. But if you did something that was kind of like a variation of Zaha or Rem Koolhaas or Frank Gehry or Norman Foster or whatever, but not the same, that would be considered architecture. That's why I use the example of jazz, saying you're playing off against a template that's there already, and it kind of has to relate to it. It can't be, it can, you go back to it and so on, but it builds off that. In other words, I don't think that human beings are that creative. In fact, even Frank Gehry, who maybe you could say he was a game changer, but he's kind of copying himself. This is the Guggenheim in Bilbao, and this is the Walt Disney Concert Hall in downtown LA. The question then is really whether architects are that creative. To my mind, we all have our signatures, by which I mean not just our literal signatures, but the way in which we express ourselves. We tend to sort of say the same things, we tend to design the same things. You could recognize someone from 100 meters away by the way they're walking, or you could recognize their voice. We always kind of say the same things. I'm not sure that we are quite so creative as we think ourselves. So the question then is really whether AI could be more creative than human beings. And maybe I should say that the key kind of question really, in order to be genuinely creative, you have to be aware you're being creative. So you have to have consciousness. Well, maybe that's the theory. But let me just kind of start with a kind of comment here from Alan Turing, where he's talking about, or conceptualizing about, the possibility of what computers could do. And he makes this comment about sonnets, about poetry. And he says, I'm sure that computers could generate poetry. But then he makes this very odd comment, which I thought at the time I didn't quite understand. But the comparison is a little bit unfair, because a sonnet written by a machine, will be better appreciated by another machine. actually, that's kind of interesting. In other words, if you think about it, there may be forms of creativity that we don't even recognize because they're so creative. And this was maybe the singular moment when everything changed in terms of the perception of AI. In 1997, DeepMind had already beaten Garry Kasparov at chess. But that was easy. I mean, but the real challenge was the game of Go. And Go is infinitely more complicated. There are more moves in Go than there are atoms in the universe. It's extremely complicated. Anyway, the challenge was set up whereby a company in London, now owned by Google, then established or developed what's called AlphaGo, an AI program, deep learning AI program, where they took on this guy, Lee Sedol, not the world champion, but one of the top champions in the world. Now, what was so interesting about this game, apart from the fact everyone was convinced that Lee Sedol was going to win, no way would AI beat Lee Sedol. Well, he lost, right? But it wasn't that was so interesting. It was what happened. There were a series of what were called slack moves that were made by the computer that all the human experts, all the human commentators were they couldn't understand. And there was one particular move, and it was move 37 in game 2. And the computer produced what they initially thought was a glitch. And the computer had been producing glitches, they thought they were glitches, and they all smiled. Another computer glitch. And apparently Lee Sedol also smiled, thinking it was a mistake. But then the smile drained from his face when he realized this was probably the most brilliant strategic move in Go ever seen. And it had never been made by a human again, but it's changed the game of Go forever. And the point being that these slack moves, what AI can do is entertain the possibility of a far greater range of options than we could ever imagine ourselves. So it's producing and thinking 5 moves ahead, producing these things that we didn't even recognize. We can't even see how strategically brilliant they are until later. So this was the point. AlphaGo showed us that moves human beings may have thought were creative were actually conventional. The question I would say is, well, maybe I'll talk about it later, but the challenge to my mind is, was it really creative, or was it just looking for the best option? And what does it say about human creativity? So the next point was, the next step was actually the next model, AlphaGo 0, that was even more powerful. It hasn't sort of hit the headlines quite so much, but this was astonishing. They developed a game of Go that taught itself to play Go. Developed an AI that was able to teach itself to play Go. And what was most astonishing was the speed at which it taught itself to play Go using reinforcement learning, because it played 4 million games of Go over 3 days. Now, 4 million games of Go over 3 days is 20 games of Go a second. Absolutely mind-boggling. And that's the point about AI. It is going to be able to do things that we just can't do. And it's already ahead of us in many ways. And what was interesting, this is a discussion with Wan Yu here and Hove Hoekland here over the summer in Digital Futures, where Hove kind of comments on one particular case, one of his projects, where the computer had generated something that none of the architects there thought made any sense. And none of them, they're all very experienced in it, but actually it proved to be the most strategically brilliant move. So my concern is that we need to be able to recognize that we are not the center of the universe, that just as Copernicus had kind of argued that the Earth is not the center of the universe, so human beings are not the center of the universe. And human intelligence is only a section of a broader spectrum of intelligence in which there might be other forms of creativity. Let me just go back to a second to this kind of question. My conclusion here is actually one of my students who writes AI software, Theodore Galanis, was saying, well, I don't think it was creative. It wasn't creative. It just searched for the best move. Now, throughout, my interest is trying to think how AI can be a mirror in which to understand human operations. Could we say that creativity was also not really creativity? Could we say, in other words, that what we call creativity, the aura of creativity, is something that we just don't understand, and therefore we think it's special, we think it's magical, but actually it's quite straightforward. It's simply a question of processing the possible outcomes and selecting the best option. So there are some deep philosophical questions to my mind that come out of this world. In other words, would this model of the Chinese room not explain the problem about creativity? We just don't know what's going on in terms of the human mind, and we think it's special, we think it's amazing, we think it's almost magical. But let's remember, there is no such thing as magic. Magic doesn't actually exist. When a conjurer is doing a trick, the conjurer is not performing magic. The conjurer is simply hiding the operations that's going through, and therefore making you think it's magic. If we think that creativity is something magical, maybe it's we just don't understand what's going on. It's nothing particularly creative at all. So let me try and wrap up with a kind of some comments about this issue of hallucinations and how it kind of maybe connects with how humans operate. So this is a TED talk by Anil Seth, who is a neuroscientist at the University of Sussex in England. He also was part of Digital Futures. We had him engage with Refik Anadol, and Refik's interested in neuroscience. And we also had Memo Acton, actually, more recently in Digital Futures as well. Anyway, what makes Anil Seth interesting is he did a PhD in AI, and now he's working as a professor of neuroscience. And he has this theory about how we as human beings are also hallucinating the world. Not quite the same, perhaps, as the way that as a computer is, but nonetheless, the term is kind of similar. So what he's arguing here basically is that the human brain is locked into a bony skull. It doesn't know what's going on outside, and it has to guess. It has to guess through a kind of process, which is to do with kind of of course, you're absorbing information from the outside world, but it's not just straightforward. What we have to do is to actually use our imagination to predict what we're seeing out there. It's not as though we know, we just have to guess what is out there. And therefore, what we're effectively doing is a form of hallucination. We don't just passively perceive the world, we actively generate it. The world we experience comes as much, if not more, from the inside out as from the outside in. And if hallucination is a kind of uncontrolled perception, then perception right here and right now is also a kind of hallucination, but a controlled hallucination. And that's the thesis. I would encourage you to watch the TED Talk. There have been 10 million hits, and it's obvious why. It is one of the most brilliant TED Talks out there, and incredibly fascinating. I'm going to skip this. Slavoj Žižek. So I want to just take this for a moment and ask this question. What I want to suggest, in fact, is that the way that we perceive the world is actually an hallucination that is based on the way that we've been trained to see the world. This is the work of Memo Acton, and what he's doing basically, he's got a series of neural networks that have been trained on a certain 4 different sets of data. This one is based on flowers. There's another one based on water. Then there's one based on clouds, and there's one based on fire. And what's happening? So here's the water. He's simply kind of like he's just doing these operations on the left-hand side, bits of cloth and things, or charges and so on. And on the right-hand side, each of these neural networks is interpreting this based on what it's been trained on. And therefore it sees, in this case, it as fire, or it sees it as flowers and so on. And that's really, in a sense, how we as humans operate. We are trained to see the world like a neural network is trained to see the world. So let me just give you one example of that. If you think about a rainbow, we all know what a rainbow is, but every child, and I'm sure that's the same in the Czech Republic, when asked to go and do a drawing or a painting of a rainbow, will do one of these. In other words, they'll give it 7 different colors: red, orange, yellow, green, blue, indigo, violet, because they've been trained to think that a rainbow has got 7 colors, but actually we know that it's got an infinite number of colors. In other words, the way we see the world is based on how we've been trained. And the same happens in architecture. If you ask somebody to think of, or to describe a modernist building, a functionist building, they'd probably think of something like this, a building by Le Corbusier and Pallotti with flat roofs and so on and so on and so on. Is there anything functional about a flat roof? No. If you come from my country, from the UK, where it rains a lot, flat roofs leak. There's nothing functional about it, but we've been trained to think this is a functional building. And this was an example of what my students did to try and illustrate a kind of version, as it were, of that memo-acton thing, whereby he's taking these his wardrobe on the left-hand side. On the right-hand side, he has trained a neural network on two sets of data. This one is a Zaha Hadid building, a research center in Riyadh in Saudi Arabia. And what it's doing is interpreting this T-shirt through the lens of the neural network and producing a form of architecture. And then this other one, this is downtown Miami. These are a neural network trained on standard tower blocks, and this is his tie on the left-hand side, and that tie is being translated into a generic tower block. So what does this mean? Does it prove that we kind of, it doesn't actually prove anything as such, it's simply a comparison, but it does suggest that we as architects are trained to see the world in a certain way. And this is where I want to introduce the notion of what I call architecturalizations, whereby we go around, and this is an example of Sydney Opera House, where Jornutson had been inspired by the sails of yachts in the harbour, that then becomes architecturalized and translated into an architectural form, as though we are doing something not dissimilar to that neural network. And this is where I come in with my critique of the discrete. And this happens in many different ways. So whenever someone like, let's say, Deleuze writes about the fold, and he's not talking about architectural form at all, he's talking about ways of thinking, architects automatically think he's talking about folding in architecture. They take the term, and the Baroque even, they think he's talking about the Baroque architecture. He's not talking about Baroque architecture, and he's not talking about architectural forms. He's talking about the folds of thought, but architects architecturalize this whole thing, and that's what they do. And this is where the discrete comes in. Gilles Retzin hears the word discrete, he's heard that the digital is discrete, and somehow translates that into discrete architectural forms. Well, that's not what it's going on about at all. And you also get this kind of issue with Mario Carpo, of whom I'm extremely skeptical, where in this book, The Second Digital Turn, he's heard that big data is messy, and therefore he thinks that this kind of 3D printed chair on the right-hand side is an example of an architecture of big data. I mean, this kind of turning of his intellectual ideas into form is absolutely banal to my mind. If I were to think about big data and think about what it means, this is what happens. Now, if you look at an Uber car, is it different to an ordinary car? No, because it is an ordinary car. So what we get with big data is not a language of forms, but new informational systems and new ways of processing information that suggest different forms of operation. So that, to my mind, this notion of architecturalization is going on the whole time in architects. They're continually hearing concepts from outside and translating them into architectural forms. Anyway, I'll skip that. So just this is my kind of view, which in a way is, to go back to the question about the swarm, what struck me as interesting about our initial understanding of swarm intelligence was it took a computer scientist, Craig Reynolds, to start with his Boids, and I should maybe put a video in this, but Boids were basically, and I'm sure that Jan has referred to these many times. This was Craig Reynolds trying to understand how birds flock, the swarming behavior of birds. And he produced a set of rules. In order to go and describe that computationally, you have to have a set of rules. And out of those set of rules, he produced a form of, he managed to replicate that behavior. And as it was as a result of that, that ornithologists or bird experts, whatever they're called, began to understand how birds flock. The same happens with AI. I'm convinced that we can use an AI as a mirror to understand how humans operate, to understand what human creativity is, and to expose the problems of questions such as the discrete. So I just want to simply mention this is the we put all these videos about this thing. If you want to do a screenshot of that, you can see the website where all these have been stored. There's also, this is Daniel Bolajan's. He's also got 3 tutorials there. And this goes back to the discussion we had at the very beginning about how this digital platform has been incredibly progressive in the sense we've been coming together on a platform. And even though this is one course for one university, Patrick Schumacher has been kind of zooming in, and Emmanuel Poe from Singapore, and Matthias Del Campo from Michigan, and so on. And we've had these most incredible debates about AI. So you can access this all for free. And I'll just simply say that we're going to do something else in the summer, which is going to be very similar to that. We're going to be looking at how we can have workshops exploring the possibility of, and especially AI. So let me stop there and open up to potential questions. I don't know if that was too long or too confusing or too whatever.
First of all, thank you very much. It was too perfect. The length was exactly what we wanted, and we still have quite some time for the debate if you're open to it.
Sure.
And we can stop whenever you say that it's been already enough. So I've got a lot of questions myself, but that would be very rude from my point to ask first. So I'm going to ask the audience here on Zoom who would like to ask or comment on something. And I'm also going to check the Facebook.
Maybe I could ask you guys questions. Is anyone there using these techniques in the Czech Republic?
So in our studio, we've been dealing with the Boyd, with flocking a lot. I made a Boyd library for Grasshopper many years ago, super simple stuff, and we've been playing around with it. And we also have some conceptual issues with that. That's one of the things that I would like to debate. But in our studio, as far as I know, we are not doing AI, but maybe somebody is.
Yeah, it's actually it's a huge thing in China, absolutely huge. I mean, and it came out of that particular match of Go, because to us, I don't know, nobody plays Go in the West, right? But it's a national game in China, and when this happened in 2016, the Chinese, they thought, holy shit, there's a computer AI is beating us at our best game, and that was what's been called their Sputnik moment. Just as the American NASA kind of woke up, and the Americans woke up and established NASA after Sputnik had gone into orbit, this was the moment when the Chinese recognized that this is absolutely crucial. And what they're doing in China is just astonishing. There's so much happening. We have about 12 different workshops every summer in Shanghai looking at AI, including Wang Yuhe and other people. And in fact, New York University, NYU, Shanghai has a whole program called AI in Culture that Ben Bratton is running. So it's absolutely huge in China. So I don't know where it's, but in the sense that Daniel Bolajan's from Eastern Europe. So, I mean, it is there as well, and to some extent, although he had to leave there to go and he couldn't work in Romania. They just dismissed what he was doing. So he went to go and work with Corp Himmelblau and Angewandte. But Angewandte certainly has a number of a couple of AI specialists there working at the moment. SciArc is pretty big on that as well. Actually, but Daniel Bolajan in FAU is surprisingly a couple of people there who are doing new things. Yeah, maybe Imre. Yeah.
Yeah. You always mention people like Corp Himmelblau, Wolf Briggs, Zaha Hadid, and all those bubble of friends from almost my generation. Does it mean that architecture after them doesn't exist because you are also not interested on them after them?
Well, but I was trained at Cambridge in England in the 1980s, and I've got to say I was disappointed. I was disappointed by I'd seen the Sydney Opera House, and I thought, wow, I want to get into this. I want to get involved in this new dynamic new discipline, and all we had was postmodernism, all that kind of neoclassical facades. So what I saw when the decon movement happened was a kind of breath of fresh air. I mean, it was misunderstanding Derrida and so on, but nonetheless, it was a breath of fresh air. It was a kind of an impulse that reignited architecture in a way. And I guess I've always been interested in the experimental, and maybe that's one extreme end. But I mean, it is quite significant, certainly now that Zaha's off it. The Zaha Hadid architects, so there's like 400 or so people working there. So but that's always been my interest. So maybe I'm seeing it through my own personal lens. I appreciate Peter Zunter and all that kind of stuff, but that's not really my thing. And I'm very interested in this kind of progressive design. And what I find interesting is that generation that includes Tom Main as well. They're now seeing there's something new now. And in fact, one of the discussions that we had in Digital Futures that's been most popular was a discussion between Tom Main and Wolf Brix that's called From Decon to AI, as though we're seeing something happening now that is in some senses another fresh burst of formal inspiration. So yeah, it's a biased view. It's a biased view, of course. I mean, I think we're all biased, right? Yeah. No, I don't want to be exclusive of that, but I guess I get excited by new ideas, whether they're theoretical ideas, philosophical ideas, or whatever, and how they might kind of ignite things in architectural debate. And I think architecture really is continually feeding off new ideas. It's like a shark. If it doesn't move, it doesn't keep moving, it dies. And so that's part of the reason why it's my own personal preference, but also I think that architecture as a discourse has to keep moving.
Exactly. Yeah, thanks. You are my person.
Yeah.
I will take the word. Now I'm not the first one to ask a question, so I will use the chance. First of all, I have to say that I love the notion that you had about architects always architecturalizing something that they misunderstood. Maybe I'm now over-interpreting what you said, but that's very often happening. Misreading something, reading stuff very literally, and then applying it to architecture.
Maybe just on that point, yeah, I just want to say I should have mentioned that that's exactly what happened in deconstruction, right? People saw the term deconstruction. They go, oh, when I started teaching at the University of Nottingham in the early 90s, I had a student who was working on that, and he got assigned the construction management instructor because they saw the word deconstruction. They thought it was about architecture. Of course, it's nothing to do with architecture. It's an architectural metaphor. I mean, Derrida uses it as a metaphor. We have to construct arguments, as it were. And he also the notion that we have a constructed way of looking at the world, which is what I was trying to say in terms of AI. We are trained to think in the world in a certain way, the rainbow having 7 colors. So we are constructed mentally, but he's not talking about physical buildings. So that was where all the confusion came in, but absolutely. Sorry. Yeah.
But it also shows that it has certain potential to actually create some sort of novelty, even the misreading. And I think that Peter Eisenman is even telling it openly that he is misreading things, and that's how he makes decisions. But
yeah, I think that there's a comment that Lacan makes: every interpretation is a misinterpretation. Every form of connaissance is a form of méconnaissance. Yeah.
But now I will come to my main question, and I will certainly not go into the criticism of AI and computation from the point where I would be worried that it's kind of dangerous and taking something from us architects. I will go from the other way around, and I would like to debate whether it really has a potential, whether it's powerful enough. And there's an issue that we are always having. Whatever project I was ever working on that was explorative, there was always the main question: what is the problem that this is an answer to? And we are struggling with this with Boyd's, with swarm simulations, because in mathematics this is being used to search the space of solutions. And when we do that, it's that exact same literal interpretation of an algorithm that is supposed to do something else, and we are reading it as something that generates forms, which is again a misreading. And we've been struggling for years to find an architecture used for swarm simulations. And my question is, what is the problem that AI is answering?
Yeah, I mean, it's a good question. I mean, to my mind, the problem is the limitations of the human mind. In other words, let me give you an example. I was at a review at the AA when I used to teach at the AA, and there was one student who came along and he said, I've looked at the problem and that there are 6 possible solutions. And it's normally either 4, 6, or 10, like the books on architecture, whatever, And then the next student, who was really super smart, really good student, came up and said, I've looked at the problems, and there are 500 or so possible solutions, and many of them are all the same, but here they are. And I think that's the challenge, is the sense that we have our own human biases. We actually can't think beyond a certain range. We can't even imagine a certain amount of things, whereas what a computer can do is just kind of lay them all out. You could even sort of take the view that kind of actually all the possible solutions are already out there. This is the view that Kostas Desidas takes. They say, well, it's all there, we just haven't thought about them. I had a discussion with him in Shanghai. He's one of my colleagues in Tongji, and we were in the hotel and having cakes or having biscuits, and he took a plate of biscuits, and he put one of the cookies behind his back and said, because you can't see it, it doesn't mean to say it's not there. And that's, in a sense, our problem, is that we only can conceive of a certain range of possibilities. Now, as the things get more complex, and this is, I think, where the kind of the issue comes in, I think what AI is really good at is strategic thinking. In other words, the game of Go, the game of chess. That is strategic thinking. Now, architecture seems to be a combination of if we were to distinguish, let's say, between urban planning and urban design, urban planning is strategic thinking, right? And urban design is more the kind of the aesthetics of it in some ways. And that's the area where it is most powerful. And that's the area where a SpaceMaker AI can say, it can think about the possible mutations. And that's another term, of course, that Kostas is thinking about the whole time. It can think about the whole range of mutations and do an overview that we just simply can't conceive of. And I think this is this goes back to Elon Musk's view, is that people just can't imagine things beyond what they can imagine. In other words, AI could be incredibly creative. We wouldn't even recognize it. This, of course, was Alan Turing's point. If an AI produced a sonnet, we wouldn't even know it was good poetry. But it is that capacity to take on board the complexities. So when you're dealing with something like an urban solution, an urban scenario, when there are so many complex factors, that's really where I think it has its greatest potential. And of course, I think if the interesting thing about human beings is that we are very quick to analyze things. I mean, if you taste a cocktail or you have some Czech beer or something, you can immediately tell if it's good or bad, right? Very immediately. So if you get like 1,000 different options, it's quite quick. You're quite quick to. So the combination is quite interesting. But eventually, I guess the point would be that we know how already AI can track our preferences. So Spotify will give you the music you like, and Amazon will tell you the books that you should read, and so on and so on. It's not going to be long before AI is going to know what architecture you like and give it to you, right? So it's kind of like out of the range of all possible architecture, it will select ones that it suspects that we will like. So that's I think the danger, in a sense, because then architects are redundant.
And isn't this common to many of the computational methods? Like, is this unique for AI? It's exactly the search of the solution space that you described, and there are many methods how to search an existing solution space.
Yes and no, because absolutely, I think that's right, and I think in some senses what you're doing is creating a solution space and then unleashing the algorithm and seeing what it comes up with. But the key difference is that with machine learning, it learns. I mean, it's not quite the same as human learning, but there's a feedback and it's learning. Now, one of the things I find interesting about swarm intelligence is actually there is also a form of learning going on there. A slime mold will learn. And in fact, some of the kind of, I think all the sort of like, let's say, amoeba and other kinds of software that have been used, that they are a kind of a primitive form of AI, but they're still learning. There's the term that's often used for I mean, Grasshopper, frankly, is a form of AI. Any form of programming is a form of AI, but it's not necessarily learning. Now, and they often refer to this kind of straightforward aspects of AI as good old-fashioned AI, I don't think the distinction is so easy, because it seems to me that swarms do learn in some ways. But yeah, that's the distinction, that it learns. Now, it's not the same as human learning. All these terms that we're using, whether it's hallucinations and hallucination, whether it's creativity and creativity, whether it's intelligence and intelligence, or learning and learning, they're different. I mean, it doesn't learn the same way as humans do. And it's a mistake to project onto AI human values. And I think that's the problem with that GPT-3 example, is people were thinking, oh my God, that avatar's got consciousness, because we project onto it. But it is different. It's very, very different. But I guess just going back to that question of that GPT-3 avatar, what is interesting in some ways is that, okay, it's not conscious, but half the things that we do are not conscious either. And to my mind, even when we, that light bulb moment when some idea pops into our brain, well, we're conscious in that we evaluate it, but did it come out of a conscious process, or did it simply kind of emerge? And that's maybe where the swarm intelligence thing comes in again, because I think the theme of emergence is actually really quite productive in thinking about how creative processes might happen.
Thank you. Let's Utku wants to ask something.
Thank you very much. Thanks for the great lecture. Actually, first, really, it was nice and inspiring. Actually, now I want to actually somehow start with AI, learning AI, thanks to the lecture. And this is my first question, if you want to start with AI, visual arts, where do we start actually? What would you recommend, where to go and what to follow? And I would like to ask you two more questions. One is about, I was reading recently the book by Beatrice Colomina and Mark Wigley, the Are We Human? And it is talking about humans as as beings, as ambiguous people, beings, and this uncertainty actually creates what the human development. And this, where do you see this the fear we have and all these human nature? It talks. This creates actually the development, the difference of humans. And do you see any way this applies, it would be something that could be used in AI to give this freedom of ambiguity to the machines? And the last question will be about...
Wait, hold on a second. I can't deal with too many. Hold on a second. First, in terms of how do you find out about it? I mean, you go to one of Daniel Bolojan's workshops. I mean, he's really good. There are a lot of people who pretend they know about AI. He knows about AI. Absolutely incredible guy. And he's so, I mean, Jan knows him very well. He is so modest. He is so modest, you wouldn't know how much he knows. He came to FIU and he presented his work, and he didn't show anything of Co-op Himmelblad that he did. And when Wolfprix was talking, he said, "Oh, that was your project, wasn't it?" And he said, "Yeah, that was your project." So he's incredibly modest, but he really knows his stuff. Of all the people, so they're on the link. Maybe I'll send you the link again. There are 3 workshops there. Of course, you need to have some of the files and so on. So it's not necessarily so good, but you can get an overview of it for sure. And I really think that he's very impressive. So we have some workshops that we're doing the summer on AI. I think we're going to get a team together on that. So there will be workshops in the summer, and even though last time round we had 80 workshops and they weren't enough, but we're going to be able to live stream them so anyone can follow those things. So I can send you through the details of that. The thing about Mark Wigley and Beatrice Colomina, I remember reading that. I forget what it was I picked up on. But I think in terms of kind of things like ambiguity and all these kind of things, they're human attributes. We can project that onto things, but it's not necessarily what they're doing. We've got to be very careful what we say. It's simply a machine that is doing something, and it's not thinking and it's not understanding. And even though maybe we do certain things without really thinking about them because they're automatic or they're unconscious or so on, we've got to be careful not to project onto AI those things. So I forget what it was I picked up. Oh, yes, I did pick up one thing on that book. He mentions the term anesthetic, which is one of my terms, and he didn't even acknowledge me, which is okay, which is great. It means that my term is somehow it's become popular in some ways. But no, I don't. Is there any particular question you want to ask me about the Mark Wheatley Beatrimina's?
Like they talk like, you know, humans actually find a solution and they're unsatisfied. Like they are not satisfied with the solution, and they find, like, they say, oh, what if I don't use this tool, and then like use this tool, and then find more and more solutions to things even though they don't need them. So like he said, like they say that this is the difference between animals and maybe also with AI. Because once the AI finds a solution and it's done. So like like it says, this is the perfect solution, but humans are never satisfied. Then they say, what if I use another tool in this case? And they get bored. Like today, like something is really nice and tomorrow it's boring. Yeah. So do you think these attributes could be used in AI, or is there any any relation we can make that could make this more, I don't know, creative, let's say, or does it make it more creative, this ambiguity?
Yeah, I don't know. I can't really comment on that, but I do think the concept of the tool is really interesting because, I mean, so the tool, I think that the beautiful term I like in terms of tools is the term affordance. So what can you do with a tool? You know, and, you know, particularly a kind of computational tool. What does it allow you to do? What is it easier to do? You know, in the old days, you know, when I was a student, we had these parallel motion drawing boards, and it was you could use a French curve to describe a curve, but you didn't know what curve it was, right? You couldn't define it. Therefore, but then with computation, we were able to describe curves. So I think what's interesting to my mind is how there is interaction. That's why I think the term swarm intelligence, the idea of interactivity, is kind of hugely important here. And when we create something, we're working with a tool, and it could be a kind of like, we could be Michelangelo with chipping away at marble, but what comes out is really as a result of that kind of process. So I think the term tool is really interesting if you think about it. And I also think the other person who's interesting in terms of tools is Andy Clark, who talks about us in terms of cyborgs, you know, and the point about human beings and why human beings use tools and animals on the whole don't. I mean, some of them do, but we are really the creature of tools, is that we have these, what they call plastic brains. I mean, neuroscientists talk about the brain as plastic and how we can adapt to certain things and take them on board. So I don't know what I would say, but I think that the concept of tool opens up huge areas. And I just want to also say that, you know, just in terms of AI, there is a danger of a bad, we say in England, a bad workman blames his tool. And there's a danger of blaming AI for various things. I mean, AI is just a system, right? And it's a question of who uses it for what. You know, if I've got a knife, for example, a knife, I could murder someone with a knife, and I could also chop up my vegetables. You know, so it's not, you don't blame the knife for killing someone. But the concept, I would just say the concept of the tool is an incredibly productive way of thinking, and the way that we adapt to them and use them is interesting.
Thanks a lot. Just like the last thing I wanted to ask is about quantum computing. It's very hot topic, and is it like, do you know if there is any anything going on with quantum computing and AI?
Yes, there's Refik Anadol, right? His last thing he did in Melbourne is kind of, he used, and I don't know about quantum computing at all. I do know that in the summer we're having this, we call it Digital Consortium. We're having a kind of platform for doctoral studies as part of our event, and there's going to be one session on quantum computing by a scientist who's did a PhD at Cambridge, not in architecture, but anyway, so there's going to be some debate. I don't know about it, actually, to be honest, but maybe I should.
Thanks a lot. Thank you.
If I may, I would like to continue about with the debate about the tool. Plus, I've got a lot of other questions, but let's talk about the tool mainly. Can you imagine or suggest a workflow and the position of any AI or machine learning within an architectural creative workflow? Is it an umbrella thing? Is it a part of the workflow somewhere in the middle? Is it a partial thing? Does it produce outputs that need to be interpreted or somehow processed afterwards, or vice versa? Is it the last post-processing moment? What is the position in the workflow?
Yeah, I mean, okay, so there are different forms of AI, and the ones that my students experiment with is kind of useless in some ways, because it's like an image and it's controlled and so on, and but inspirational. But I mean, in fact, there are people who work in a more straightforward way using these tools in terms of a kind of pipeline of production. And actually, they're not I mean, some of these the tools that are kind of most popular, like Autodesk, their stuff is not advanced, right? It's really good old-fashioned AI. This was it Dreamcatcher and things. So you can use that as part of a workflow. I'm not really the person to really kind of comment on those things, since I'm no longer practicing as an architect. But my colleagues who work in more practical ways criticize the GANs as being kind of like very imprecise and so on. But yeah, you can use those in a very pragmatic way, and that's in some ways actually what SpaceMaker AI, that was the company that was bought up by Autodesk. It's not deep learning at all, really. It's not deep. I mean, what Wan Yu's doing in Xcool is, and it's really kind of pushing the boundary. But a lot of these things that they use AI, actually, to be honest, here's the thing that's kind of interesting, and that is to say that AI, as I mentioned, is invisible. You don't know it's there, but it's there, right? The danger of that is there's the danger that you could use that as a marketing tool. In other words, inverse camouflage. Camouflage, you pretend something's there, so you pretend something's not there, but it is. Well, with AI, you can pretend it's there, but it's not. So if you've got any company that's got AI in the name, it probably means they're not using AI. And that's actually the case, I think, with SpaceMaker. There is a company, Space Factory AI. And I met this guy, David Mallard, I think his name is, at a conference in Shanghai. And I was working on it. I said, what are you using AI for? And they said, oh, well, we're not, but we intend to, so it's a very good marketing tool. So one of the chapters in my book, I finish off with this kind of comment: beware the AI of marketing, which is a bit like the beware the Ides of March, right? Because people are using it in a way that's not there. So people will use it, and most people who kind of claim they're using it actually aren't, and it's a marketing tool. So yeah.
But nevertheless, let me rephrase it a little bit. Speaking of Xcool, or what Daniel is doing, that's a series of pixels. That's a 2D flat image, and I'm pretty sure there would be a possibility to turn it into something that might be architectural, even the 2D image, pixelated image. Can you imagine that being something applicable in architecture, even if not the production architecture, even in architectural speculation?
Well, that's exactly what Daniel's working on right now, and maybe I can send that link to those discussions that were going on. He is trying to explore the possibility of turning it into 3D, and I could only refer you to what he says. But it's challenging just in terms of the computational power, right? Already the GPUs just to do a GAN, what you need is a huge amount. The point being that's kind of like the only reason my Refic analog can do what he does is he uses the NVIDIA GPUs. So the computational power is huge. There is this, what's it called now? PyTorch 3D is something that I think Facebook started developing, and that's been used, but actually not very successfully, frankly. I mean, Matthias Del Campo will tell you that he uses it, but he produces some very strange stuff with it. So, these things. I mean, the thing is that what strikes me about this is the way in which the speed of development. Now, and whether we call it Moore's law or the law of diminishing returns, it's frightening how quickly these things are happening. So it'll be with us soon. But I think now, no, not just yet. But no, but let's. I mean, one of the things I think about ArchiGANs, which is just a straightforward master's thesis done by Stanislav Chai, who went to GSD, and that is say that he recognized that we, as architects, we operate in 2D anyway. A plan section elevation is 2D, and he was using that as a kind of way of opening up. But I think I completely agree. The real potential is when you start working in 3D. Yeah. will come.
I think there is a question from Dan Svitek.
Basically, my question was a little bit going back to the thing you said in the beginning of the discussion, that you're not going to go into the whole ethical area of this, but maybe just a little bit of that. I was recently saw a lot of these articles and podcasts where they were discussing, especially in the main data sets the AI is dealing with now, like the face data sets, how bias is a big deal with there, and how just the basic representations of how different people are there. So I think in architecture, it's the bias should be actually is going to be more beneficial, because right, if we want to, so the bias should be actually encoded in it, because we want to do something like that, or more like and basically the whole as you would say, well, not creative, but in sort of creative way, we want the bias to be there. So is it like playing then in our favor, let's say? I don't know.
Yeah, I mean, the question of bias, there was a whole session, MIT session, on it about two or three weeks ago, where they were looking at that kind of question. And it is a big issue, for sure. And I don't, well, okay, there are two aspects of this. One is to say that what we're getting, of course, is human bias. I mean, the data, the bias in the data is already human bias. That's why, just to go back to that GPT thing, where that avatar was talking and was saying, you know, are you sentient? This, he says yes, and he does that because searching across the internet to find out what humans would say in that situation, he's just giving what humans. It's not lying, because they're not thinking, they're not actually able to conceptualize the notion of lying. They're just kind of giving us back what we would do. So in a sense, the bias is already embedded in what we're doing in the first place, which I think is having said that, there are certain measures that happen, and I don't know the technical details of this, but they kind of exacerbate those biases. So, you know, it's not quite so straightforward. All I would say is that we're all biased, right? We're all biased. We all have our. I think the big mistake that Americans make is to think they're free, that they're free thinkers. We're all controlled by our own ideology. Yeah, I mean, that's what. That if you know Louis Althusser's theory, there are two forms of control. One is what he calls repressive state apparatus, which is the military and the police. You can see what's going on in Russia these days, right? And then there's this thing called the ideological state apparatus, which is controlling our thinking, even though we don't know that. No, it's controlling our thinking, just in the way that I was showing you. Our view of the rainbow is constructed, it's controlled. So we have bias in everything we do already, I would say. Just to say, I put a link into the chat. I don't know if you could. That's where all the lectures about AI are controlled. There's a theory. I think the theory of the digital was a course I gave, and also there's some the 3 workshops that Daniel Bolojan gave are there. So that one about colleges of communication and the arts.
I'm not sure if you said that, but I think that I've heard that you mentioned that there is a website where people can actually try the AI tools. Could you also put that into
it's there. It's not trying the AI tools. It's Daniel Bolojan taking. There are 3 workshops there on style guns. They're worth looking at. And also there's a discussion that we had a series of discussions every week with people like, you know, Patrick Schumacher and things dropping in, which is incredibly productive. Also, there's a fantastic thing on we had Memo Acton join us as well, and Anil Seth. That was a super interesting session. So yeah, there's also some stuff from Digital Futures last summer, but things are getting updated as they go, right? So the more recent, the better.
Neil, if it's okay, let's take one more question from Zoom. If somebody wants to ask something from Zoom, if not, there was a question on Facebook, but let's first prepare people on Zoom. Okay, let's read the question from Facebook, but I think it's kind of interesting. It's from Gregor Balinsky. He says, I posted it into the chat, so you can read it, but I will read it aloud. He says, cool lecture, what do you think? Couldn't be a problem with AI that it will not propose alternatives to what we do not like based on our previous choices, but in real life, we would choose it because it is good. For example, like random song we heard by mistake. Do you think that we will close in the bubble?
That's a good question. I mean, actually, it's a problem in politics right now, right? In terms of kind of, because the bots are kind of recognizing what news we like, you know, and in American politics, there's been this kind of, you know, this division. You're getting fed, I don't know, Fox News, kind of right-wing news versus other forms of news, and it is leading to a huge divide, which is a problem. Yeah, the question about how do you open up the possibilities of things, that's in a way what I was trying to get at, the difference between something that is interpolating and something that is extrapolating. So in that sense, if you have a straight data set and things, it will only give you something within the range of that data set. So if you're putting Zaha buildings in there, you just get Zaha buildings. But the possibility of using cycle GANs, which is kind of breeding one off against another, that opens it up in a way. So you could breed, I don't know, Zaha buildings with I don't know, orchids or something like that, and that could produce a range of things way beyond what Zaha would do herself. I mean, the interesting question though is and that's in a sense I showed that guy, the computer scientist Ahmed El-Gamal, who has this thing called creative adversarial networks, and maybe I should just stress that more. What was interesting about that is that he recognizes that there, and very similar to my way of thinking actually, he recognizes there's a canon. There's a canon of what is acceptable art, let's say modernist paintings, and you know, you can't vary too much on that, otherwise it's not art, right? Just as what I was saying about the pineapple, if you produce a pineapple, that's not architecture. You've got to be a little bit like Rem, a little bit like, so in a sense, you've got to, if it is going to suggest something, it can't be too crazy. Otherwise, we wouldn't recognize it as being creative in some ways. And a bit like, you know, Alan Turing's comment about the sonnets or the move made by AlphaGo, we wouldn't recognize it. So, but yeah, it's good to try and break up and destabilize things. I mean, that's an interesting kind of question, because you know, whenever I'm on Amazon, I do get books suggested. I sometimes get my own books, right, suggested. But you know, they tend to know roughly what you've seen before, and you think you might like something else, not so dissimilar. So I don't think it's going to be too much of a problem of it kind of closing the loop of having too much of a bubble. I think that you could tweak the algorithm, right, and just get it to open up in a way. So. Yeah, but I think but I would say it's maybe the opposite way around. It's the randomization. In other words, we only think of certain things at the moment, and what it's doing is throwing out other possible suggestions that we think, oh, I hadn't thought of that. I guess that's my point. I think I would turn that question round and say, well, actually, that's what it's doing already. You know, that example of the AA review, I've looked at the problem, there are only 6 solutions. Of course they're not. You know, we have our own biases. I mean, in a sense, that's the other aspect of bias. We're limited by our own biases. We can't think beyond them. So, yeah. Someone's also put that link into the thispersondoesnotexist.com. It's pretty incredible, right? I mean, it's kind of scary. Yeah. Well, I'd simply say that I think this is this is an area that's really rapidly developing, and it's kind of watch this space. You know, it's since 2019 that I think these things have happened. I gave a paper at Acadia in 2019, and I was talking about how, because it was literally that was the moment, the first ever exhibition on architectural AI came out then, and so it's been 2 years since then, 2 years, and that's nothing. That's nothing. And I think there's a comment that's made by Ben Bratton, and maybe I should wrap up with it, say that Ben Bratton makes this comment, you know, in terms of computation itself, we are still in what he calls the silent movies period. In terms of the history of movies, we're still in the kind of, you know, Charlie Chaplin stage kind of thing. So, you know, I think in terms of AI, we're even more further back. But But this artwork does not exist. I want to try that one out actually. It's, you know, it's really watch this space, and it's a very exciting time, I think, for architecture. So I've seen other things coming out in architecture. At some point there's a kind of proto-postmodernism developing in architectural circles in some schools, which horrifies me as much as the actual postmodernism of the 1980s. So I'm hoping that this is going to open up a new kind of way. This cat does not exist. I gotta check this out. So anyway, I hope there's something that that you can find useful.
Thank you very much. It was incredibly dense and informative and smart. And I was putting together a list of questions. Whenever I wrote it down, you just answered that. And it's a very challenging moment for anybody who is supposed to ask something meaningful, because you basically covered all your arguments in a brilliant way. And it's also wonderful to see and observe the way you build up your argument. That's a meta comment from me. I need to learn that as well.
You know, I think one thing I would say is that you've got to think about these things. And I had to write this book, and no one's written about it before. I think now that Emmanuel Coe has got a book out, it's quite short, but actually you've got to think through this, and it's not so obvious. No, it's not so obvious what's happening. But and my book, which is coming out in October, will be out of date, completely out of date before it comes out. But it's important to start somewhere, you know. And I think this is really, and I would just say as a theorist, this is really exciting for me, right? Because when it comes, you know, I used to work in the world of kind of critical theory and Slavoj Žižek, and I still do to some extent, right? But I thought, let's go and embrace this kind of new world of computation, because I was teaching at the AA and Columbia and all these progressive schools. But it's been quite hard to theorize it. I mean, the robotic arm, what can you say? It's kind of doing this kind of thing. But AI really raises some interesting theoretical questions, you know, not only the question of consciousness, but to my mind, it really does become a mirror in which we can understand what it is to be human. And I think that there's unbelievable material there in terms of theory. So it's just the start. And I'm sure someone's going to trash my book, which is good. But there should be a debate going. And the only thing is frankly, that this whole process of writing books is just too slow. If it takes 3 years to get an AD out, I mean, the world changes in 3 days, not 3 years, right? I mean, so, but still, anyway.
I was about to say that you chose a very conservative and slow medium, but that's not completely correct, because you're also very present online all the time and updating the stuff. So I think there is very little you can do about this thing to be outdated.
Well, I mean, that's what in digital futures, that's what we're kind of thinking is, first of all, I mean, we make everything free, which is, you know, everyone kind of donates their time for free, which is great, you know, because architects love architecture, right? They're happy to do it, even if it's for free. But the point is that you can do things very immediately then. You can do things, and we see that our events we have every Saturday, we put something on and it's available all over the world. It's a bit like a kind of combination of a TED talk and an AD. It's free like a TED talk, but it's better than an AD because ADs take so long. So you can literally suggest something. And we had someone pull out a few weeks ago, and I invited Zaha Ko to do something, and they just in 2 weeks they put together this thing, and now they're something like 6,000 hits on it. So it is and maybe you don't even need to have books anymore. Maybe the future is kind of YouTube videos. I don't know. But I mean, our problem is we're generating so much material we haven't managed to publish it as such. But I don't know. Still, it's an exciting time. So, and it's great to be able to engage with you guys in Prague. Let me just finish by saying that I was taught by a Czech academic, Dalibor Vesely. We used to fight a lot because he was very conservative. And but anyway, you know, I got to appreciate. He was a very cultivated. He died recently. Very cultivated individual. And I always enjoyed going to Prague, and your beer is absolutely amazing. So at some point, it'd be nice to come to see you guys, but we're stuck in our COVID world at the moment. But anyway, so I would just say that, I mean, maybe we can pass on information about this thing in the summer, and as many architects and students from the Czech Republic, in fact, the whole of Europe can come and join in because it's all available for free, and to be continued, shall we say.
Neil Leach, thank you very much for your passionate talk, and of course we would like to see you here in Prague. Definitely, I think it has to happen very soon. Thank you again for your energy. Also, thanks to my colleague Jan Pernetsky for fantastic moderation. Also, thanks Hugo Fekar for his support for our PR and all those things. Thank you to all my colleagues, and thanks to all visitors joining us tonight. And we are looking forward to meet on person.
Yeah, great. Thank you for the invitation.
Thank you for being here. We will send you a follow-up email. We are off Facebook now, so we'll send you a follow-up email thanking you again with all the technicalities that we need to take care of. And I really personally wish that we could continue with the debate. There is a lot of provoking thoughts that I would really like to challenge. And yeah, I hope that there will be a chance sometime soon again.
You want to invite Daniel here? I mean, he's incredible.
I'm certainly going to do that.
Yeah. Okay.
Okay.
Thanks, guys.
Thank you very much. Have a nice day.
Thank you very much.